Next up in Chapter 4, we're going to look at the idea of the regression line, which is also known as the line of best fit. The regression line is a tool that we're going to use for making predictions about future observed values. Not in our data set, but things we see in the future. And it's really just a summary for the linear relationship that we're seeing. We feel more confident in a regression line associated with a stronger scatter plot. So the higher our R value, the higher that absolute value of R is, the better we can feel about the accuracy of our predictions from this regression line. Now the regression line has the form y equals a plus bx, and this is like the form y equals mx plus b that you may have seen in an algebra class. However, we're going to stick with this form a plus bx, and this goes back to a previous video. All of our calculations in Chapter 4 come from our calculator by going to the Stat button, over to Calc, and then number 8. Note that number 8 has the form a plus bx, just like we see in the notes. 4 has ax plus b. It has the x associated with the a, not with the b. That's why we're always going to go to number 8 here. Back to our notes, looking at the a and the b. The a part of this equation for the regression line, this is our y-intercept. And what that y-intercept is in the concept, in the context of our statistics class, it is the predicted value for the response variable, that's for our y, when x is 0. So when the explanatory part, the x part of our data is 0, this is what we would predict the y to be. Think about it as the initial value or the starting point. Now it's not 100% guaranteed that when x is 0, this is the number we'll get. It may be extrapolation, but that's what we can think about it as being. The other part of the formula, the b, this is our slope. And for statistics, we're going to think about it as a prediction for how much the response variable, once again that's y, will increase or decrease if the explanatory or the x increases by 1 unit. That b is how much the y should go up or down as the explanatory, as the x goes up by 1. And it's always as the x is going up by 1 in the cases that we're going to see. If b is positive, it's increasing. Should be a positive trend in your scatter plot. And if b is negative, it should be a decreasing scatter plot, should be a negative trend. To make a little bit more sense of this, let's look at an example with some data. Let's actually get the regression line from our calculator and discuss what these components mean. In my data set here, I have 10 cars. I have their miles per gallon in the city. I have their miles per gallon on the highway. And this is the scatter plot that I see. And this data seems to be fairly linear. Draw a pretty good line. I don't see a clear curve here. So I can make some calculations. If I want to find the regression line which has the form y equals a plus bx, I'm going to go to my calculator. On my calculator, to get my data in, I hit the Stat button, hit Edit, and I'll enter the city miles per gallon into L1 and the highway miles per gallon into L2. Now that this is in, for my calculations, I go to Stat, over to Calc, and I want number 8, the linear regression in the form a plus bx. You can just hit the number 8 and then enter until your list is populated. So I can see my R is very high for this relationship. It is 0.998. It's a strong linear relationship between city miles per gallon and highway miles per gallon. As well, I have y equals a plus bx at the top. This is what the a would be, and this is what the b would be. If I round that a and that b to one decimal place, it would be y is equal to 10.9 plus 0.8x. Note that I don't have a car that gets 50 miles per gallon in the city. But let's say a car comes out next year that does get 50 miles per gallon in the city. I can make a prediction for its highway miles per gallon by plugging in to that equation. I would just say 10.9 plus 0.8 times that 50. So I get 50.9 highway miles per gallon as my prediction. It's important to be able to interpret these numbers. What do these numbers mean, the 10.9 and the 0.8? The 10.9 is our y-intercept. It's our prediction when x is 0. We would predict that a car that gets 0 miles per gallon in the city would get 10.9 miles per gallon on the highway. Now that doesn't really make sense. If you're getting 0 miles per gallon in the city, that means your car's probably not running. You probably get 0 miles per gallon on the highway. This prediction is off because it's an extrapolation. We don't see a car anywhere close to 0 miles per gallon. The lowest we see is 8 with the Bugatti. So this is probably off. But that's what it means. This second number, the 0.8, this is our slope. This is how much we predict the y, in this case the highway miles per gallon, to increase by as the x goes up by 1. And again, it's always up by 1 for this slope. So we would say as your city miles per gallon went up by 1, as you went from 14 to 15, or 15 to 16, or 16 to 17, your highway miles per gallon should go up not quite by 1, but by 0.8 miles per gallon. So if you added 1 city mile per gallon, you would add 0.8 to your highway miles per gallon. If you added 2 city miles per gallon, you would add 1.6 to your highway miles per gallon. If you added 3 city miles per gallon, you would add 2.4 highway miles per gallon. We'll talk about this slope and y-intercept a little bit more in a future video.